So local and global extrema. So we've talked about this idea before, but let's say we have a graph, and maybe it goes like, well, I was going to do it a little bit different. There it goes. Let's say it goes like this, something like this. Now, notice that its end behavior is down to the left and down to the right, okay? So those keep going. So our local min would be right here. That would be a local min. And then by global, they mean in the vicinity. But it's the highest one, okay? So you'll notice I have two extrema, two other extrema. This would be, or maxes, that's what I want to say. This would be a local max. But this one here is even higher, and it's the highest point. That would be a global max. There's no global min in this picture because of the end behavior. Keeps going on and on, right? Down, lower and lower. So there's no global minimum in this picture that I have. So your local ones right around the vicinity, those are, a max or a min. It's a max if it's going from increasing to decreasing. It's a min if it's going from decreasing to increasing. The global is going to be the one that's the highest point if it's a max, or the lowest point if it's a min. Okay, so you might be thinking, well, but didn't we already do that, when we were talking about absolute maximums and minimums? I tend to think of the absolute ones more in terms of a defined domain that's not, from negative infinity to infinity. So if the domain is restricted, then I tend to think of it more in terms of the absolute extrema. They use global and absolute interchangeably sometimes. I noticed that in different, books and stuff. Global is not always a word that I've seen in all textbooks, but absolute is a little more common. But I was going to give you an example. So let's say you have something like, and this is kind of a minor point, but you have local mins, right? That would be a local min. And then this would be, I would call it an absolute, but you can use the word global, absolute, or global min. And then we have maximums, right? So here's a local max. And then you can't really say this is a local max over here. What's that, It's not really anything. It's not the absolute max. It's just an end point, okay? And the reason you can't say it's a max is because it's not changing from increasing to decreasing. It's stopping right there. And then you have this one here. You would say that is an absolute max. I wouldn't call it a global max because I don't know what's going. I don't know if it's continuing on up that way or if it's going to curve, okay? So I don't know if that's helpful. If it's not, just ignore it. Like I said, that's not going to be a big point, but I just wanted to kind of explain how I'm looking at the difference between global and absolute. So they use them interchangeably, but I would just throw that in there to say, well, why did we have the two terms? Okay, that's my explanation. Do all polynomial functions have global extrema? No. The answer is no. You could have something like this, and there's no global here. You do have a local, We have a local max here. And a local min here. But I don't even have to have those, so let me scoot this up a little bit. I could have something, a graph that goes like this, and I don't have any locals or globals. That's just a crazy little graph I have there. Not too crazy. It's really, I was supposed to make it like the cubic curve, but it needs a little more curve to it. Okay, probably more information than you need to know on this.